Welcome to our exploration of cognitive processes, where we ask how we perceive the world, learn new things, and make decisions. In this session, I'll guide you through the core mechanisms of human cognition and highlight how cognitive psychology impacts daily life and professional fields, helping you see why these ideas matter beyond the classroom. Cognition is simply how we acquire, process, store, and use information. And this slide shows the main functions like perception, attention, memory, and language. Think of cognition as the toolkit we use to make sense of the world, solve problems, and connect psychology with fields like neuroscience and artificial intelligence. Let's look at the history and importance of cognitive study, tracing ideas from philosophical pondering to early psychology, through behaviorism, and into the cognitive revolution that turned attention back to the mind. This background helps explain why studying cognition matters today for understanding behavior and advancing AI, education, and user experience design. Perception is the process of turning sensory inputs into meaningful experiences, and it relies on both bottom-up signals from the senses and top-down influences like expectations and context. The slide's visuals remind us that our eyes and ears feed data to the brain, while prior knowledge shapes how we interpret and respond to the world. Visual perception begins when light stimulates the retina and neural signals travel to the visual cortex, where the brain organizes information using Gestalt principles like proximity and closure. The diagrams on this slide show how object and face recognition unfold, helping us quickly identify objects and people in complex scenes. This slide highlights auditory perception and the other senses beyond vision, from taste and smell to touch, pain, proprioception, and the vestibular sense. Each sense converts different physical or chemical signals into neural information, and together they give us a rich, multi-sensory picture of the environment that supports action and balance. Attention is about directing limited cognitive resources towards specific information, whether internal or external, and this slide shows why that capacity is crucial. Because attention is finite, it affects multitasking, learning, and everyday activities like driving or conversations, and understanding its limits helps us design better tasks and environments. There are different types of attention that serve different goals. Selective attention filters out irrelevant input. Divided attention handles multiple tasks at once. Sustained attention maintains focus over time, and processes range from automatic to controlled. Thinking about these types helps explain why some tasks feel effortless, while others demand deliberate effort. Memory is the cognitive system that stores, retains, and retrieves information, and it underpins learning, experience, and decision-making. This slide introduces the multi-stage model of memory, sensory input, short-term processing, rehearsal, and transfer to long-term storage, so we can later unpack each stage and how it supports behavior. Sensory memory captures fleeting input in iconic and echoic forms, while working memory provides limited capacity, storage, and processing for current information. The slide shows components like the phonological loop and visuospatial sketchpad working under a central executive to juggle information, which explains why complex tasks can quickly overload our mental workspace. Long-term declarative memory covers facts and events that we can consciously recall. Semantic memory holds general world knowledge and concepts, while episodic memory preserves personal experiences and their contexts. The images on this slide help distinguish remembering a scientific fact from recalling a birthday, showing how different memories serve different functions. Non-declarative, or implicit, memory operates below conscious awareness and includes procedural memory for skills like riding a bike or typing, as well as priming effects and conditioning. This slide emphasizes that many behaviors are shaped by past experiences without deliberate recall, explaining why practice and habit are powerful learning tools. Memory relies on three core processes: encoding to get information in, storage to retain it over time, and retrieval to take it back out. And the slide also highlights why we forget decay, interference, or retrieval failure. Understanding these steps helps us apply strategies to improve learning and remember information more reliably. Language is a system for expressing thoughts and emotions, built from phonology, morphology, syntax, semantics, and pragmatics. This slide maps how sounds combine into words and sentences, how meaning is formed, and how social context shapes language use, underscoring that language is both a cognitive skill and a social tool. Language acquisition and processing involve developmental stages from babbling to complex sentences and rely on neurocognitive systems like Broca's and Wernicke's areas. The slide shows how brain regions collaborate to produce and comprehend speech, highlighting that language emerges from both biological foundations and environmental interactions. When we approach problem solving, we can use different strategies depending on how well defined the problem is. Algorithms offer step-by-step guarantees. Heuristics provide fast rule-of-thumb shortcuts. Trial and error explores possibilities, and insight delivers sudden solutions. Choosing the right approach depends on the problem's structure and our available cognitive resources. Decision-making involves evaluating and choosing among alternatives, but it is influenced by heuristics and cognitive biases that can skew judgment. The slide contrasts decision-making with reasoning, showing inductive approaches that build general conclusions from examples and deductive approaches that apply general principles to specific cases, helping us understand everyday choices. Cognitive neuroscience links brain structures and networks to cognitive functions, illustrating how different regions coordinate perception, memory, and more. The slide also highlights brain plasticity and advanced research tools like fMRI, EEG, and TMS, which reveal activity patterns and causal relationships that inform both theory and practical cognitive training. Emotion and cognition are tightly intertwined. Emotions shape attention, influence memory formation, and bias decision-making, while chronic stress can undermine cognitive performance. The central graphic on this slide shows a dynamic exchange between heart and brain, reminding us that cognitive processes cannot be fully understood without considering emotional states. Cognitive psychology has many practical applications, from improving education and learning strategies to enhancing human-computer interaction and user experience, applying cognitive behavioral therapy in clinical settings, and supporting forensic assessments. This slide summarizes how insights into cognition translate into better teaching, design, therapy, and legal practices. To wrap up, cognitive psychology covers perception, attention, memory, language, and thinking, and understanding these domains gives us valuable insight into human behavior and practical applications across fields. This introduction sets the stage for deeper exploration, and I welcome questions and discussion to clarify any of these concepts as we move forward.